Hello everyone, welcome to Math Mechanics channel. This is Vignesh. Today we're going to talk about two integral problems. I have first problem, integral cos of theta minus 1 divided by sine square of theta minus 1 d theta. That's the first problem. And the second problem is integral e to the power of theta dot cos theta d theta, dot meaning multiplication, e to the power of theta times cos theta d theta. So let's see how we solve the first problem. Okay, so most people think most people do not think, but most people do the U substitution method. They plug in something for cos of theta minus 1 and then derive and then do some algebraic manipulation and then basically introduce a new variable called U or some t. But I'm going to follow a slightly different approach. It's the same kind of thing. You will end up having same solution, but it's just a different way of thinking it. Okay, so I have cos of theta minus 1 d theta over sine square theta minus 1. Okay, so in this problem the numerator is cos of theta minus 1 d theta, which is nothing but the derivative. Cos is nothing but the derivative of sine theta, right? So derivative of sine theta minus 1, if I derive that, I will get cos of theta minus 1 d theta, right? So that is exactly what I have. So instead of writing cos of theta minus 1 d theta, I'm gonna write it as d of integral d of sine of theta minus 1 divided by sine square theta minus 1. So what I just did is rewrite the cos of theta minus 1 as derivative of sine of theta minus 1. Okay, now it is derivative. Now we are integrating the integrand with respect to sine of theta minus 1. Basically I changed the differential from d theta to d of sine of theta minus 1. So now it is in the form of integral dx by x square, right? So for example, you have integral dx by x square. What would you do? It is simply x to the power of minus 2 plus 1 divided by minus 2 plus 1 plus c, right? So in the same way, when I'm integrating with respect to a function, I can do the same thing. So now I have integral d of sine of theta minus 1 divided by sine square of theta minus 1. So I can write it as sine to the power of minus 2 plus 1 of theta minus 1 divided by minus 2 plus 1 plus c. That is nothing but sine to the power of negative 1 of theta minus 1 divided by minus 2 plus 1, which is minus 1. That is nothing but minus 1 by sine of theta minus 1 plus c. Basically minus 1 by x or minus 1 by sine theta minus 1. So, or you can also represent sine as cosecant, minus cosecant theta minus 1 plus c. So both are correct answers. Let me know in the comments if you know this method or if you understand this method. Maybe it might be more difficult than the U substitution, or maybe it is easy for you than U substitution. Let me know in the comments below. Okay, now let's solve the second problem. Integral e to the power of theta times cos theta d theta. This problem is an example of integration by parts. We have to use integration by parts formula for this particular problem. So integration by parts is integration by parts, right? So integration by parts is useful when you have two different functions, like we have an exponential function and a trigonometric function, two different functions. So we would use integration by parts. So for example, u is a one function, v is one more function, then we would do u integral v d theta minus integral u prime integral v d theta d theta. This is the integration by parts formula. How do I choose my u and v functions? Like one is inside and the other is outside of the integral, right? So how do I choose? By ILATE rule. I represents inverse function, L represents logarithmic, A represents algebraic, T represents trigonometric, and E represents exponential. So in our case, we have a trigonometric and an exponential function, right? But in ILATE, T comes first. So that means we have to consider cos theta to be U and e to the power of theta to be V. So integral e to the power of theta dot cos theta d theta, e to the power of theta is V and cos theta is U. So apply the ILATE rule. Cos theta is outside and we are integrating e to the power of theta d theta minus integral. Now we are deriving cos derivative is negative sine theta, and integral e to the power of theta d theta d theta, right? Perfect. Let's keep on solving. Cos theta integral e to the power of theta d theta is e to the power of theta, and we have minus times minus here, so that becomes plus integral sine theta, and integral e to the power of theta d theta is e to the power of theta d theta. Again we have a trigonometric function and an exponential function. So again we would have to apply the ILATE rule. We would apply the ILATE rule as many times as possible until we get a required solution. So in this case we would have to apply just twice. So sine theta times e to the power of theta, so sine is u and e to the power of theta is v. So apply the ILATE rule again over there, just dropping down cos theta and e to the power of theta, and ILATE rule. E to the power of theta is inside, sine theta integral e to the power of theta d theta minus integral sine derivative of sine is cos theta times integral e to the power of theta d theta d theta. Perfect. Cos theta times e to the power of theta, sine theta integral e to the power of theta d theta is sine theta times e to the power of theta, and then we have minus integral cos theta times e to the power of theta d theta. Okay, and what is on the left hand side? Left hand side we are deriving integral, we are integrating e to the power of theta times cos theta d theta, right? So integral e to the power of theta cos theta d theta. But if you look here, we have left hand side integral e to the power of theta cos theta d theta, and on the right hand side as well we have minus integral e to the power of theta cos theta d theta. So what we will do is bring this to the left hand side, making this to be positive. So left hand side will become 2 times integral e to the power of theta cos theta d theta, 2 times integral e to the power of theta cos theta d theta, and the remaining thing is e to the power of theta. If I take e to the power of theta common from both of the terms, it will become e to the power of theta cos theta plus sine theta, and integral e to the power of theta cos theta d theta is e to the power of theta by 2 times cos theta plus sine theta. Since this is an indefinite integral, we would have to add an arbitrary constant. So integral e to the power of theta cos theta is e to the power of theta divided by 2 times cos theta plus sine theta. I hope you understand the problem. I know it is a little difficult, but if you're stuck, please go back and see what I am trying to say. And if you still have further doubts, you can comment down below. I will try to explain it. And yeah. I hope you like the video. If you like it, give it a like, subscribe for more videos, and I will see you in my next video. Also, I will put this notes in the description as a link. You can download it for free, and it would be useful for anyone who's solving similar kind of problems. Alright, so I will see you in my next video. Alright, bye bye, take care.